Okay, now let's continue. Now, the density of kerosene, since we're working with kerosene and water, the density of kerosene is less than 10 kilogram per meter cube. Why the density of water? Why the density of water is its value? We know that to be 1,000 kilogram per meter cube. So automatically, the relative density, which this particle is all about, is 0.81. That will be the relative density of kerosene. Now, quickly, since we know the relative density of kerosene now to be approximately 0.81, now what's the formula that connects? Because if a body is submerged inside a fluid, there will be a buoyant force. A buoyant force is also what we refer to as the upthrust, the upward force that acts in opposite direction to the weight of the fluid. So now, if I submerge this mass now, presently the weight in air should always be recorded, which is the original weight. The weight in air here presently is 1.1 newton. So the weight in air of the mass there, weight in air is 1.1 newton. That's the weight in air. So if I submerge this now into this fluid, water, if I submerge it into this water now, you should know immediately there will be a buoyant force opposite in direction to the weight of the fluid. So the weight will be totally reduced. So I'm having 1.0 newton. I'm having 1.0 newton. So that's weight in water. Weight in water, 1.0 newton. So now if I submerge it into, I'm taking this to be my kerosene. If I submerge this, please make sure you always clean your mask when you're done with your particle. Clean it, clean it, clean it. That's one of the precautions. Now I submerge it into, I'm taking this to be my kerosene. I submerge it, please let it be stationary before we continue. Now, since kerosene has a density less than water, you should know immediately this should weigh lesser too. Are we together? This should weigh lesser. So automatically the weight here now will be 0. Okay, that's 0.95. 0.95, that's the weight in kerosene. Weight in kerosene is 0.95 newton. But please, if you notice how I was looking at it, make sure you always avoid parallel error. So I would have come to this. I'm just trying to save time. So always look at it. Let it be horizontal to your eyes. Let the region be horizontal to your eyes. So with that now, I'll quickly let's check if my relative density is actually in line. So I'll be having relative density here is equal to weight in air. Okay, since we're dealing with two different liquids, I'll be working with upthrust in what in kerosene, upthrust in kerosene over upthrust in water. Upthrust in kerosene over upthrust in water. So how do we calculate upthrust? Upthrust is just simply the loss of weight. The loss of weight. A body that was weighing 1.1 in air now weighing 0.95 in